Hello, my name is Mike Lorenzo, and in this presentation I will give an overview of smart materials used for food packaging applications. In this presentation, I will give two examples of active packaging, an example of intelligent packaging, and I will conclude with a recent paper on the use of phase change materials in smart food packaging applications. For each application of smart materials in food packaging, I will highlight the materials, applications, performance, mechanisms, and suppliers for these smart materials. The first article I would like to highlight is entitled "The Active and Intelligent Packaging Systems for a Modern Society." This is written by Carolina Rialini and Begonia Marcos in the Journal of Meat Science 2014. In this article, one of the properties highlighted for smart materials in food packaging applications is antimicrobial properties. This is of much interest for food packaging applications. Microbial growth can result in changes in the food's taste, in the aroma, and also the texture of the food. It is generally undesirable for the customer. Some of the solutions designed for antimicrobial systems are plastics for food packaging, compounded with metallic elements such as silver, zinc oxide, and copper. These are most commonly compounded into the plastics during processing. One example of this is a silver master batch from BASF, or copper, silver, zinc master batches supplied by a company called Microban, which are used during the plastic processing. According to a company called RTP, which does plastic compounding, when these silver additives are contacted by ambient moisture, they undergo a electrochemical reaction that releases silver ions. These silver ions can disrupt the microbes and also render them useless for their functionality and growth of the microbes. One hot item in the antimicrobial field is the use of antimicrobial nanoparticles in plastics for food packaging applications. The use of antimicrobial nanoparticles is due to the increased surface area to volume ratio that nanoparticles exhibit compared to particles of larger size. This surface area to volume ratio gives unique properties to nanoparticles and gives more effectiveness to the silver nanoparticles. Rialini and Marcos cite a study done by Akbar and Amal in 2014 in which they developed a sodium alginate film containing zinc oxide nanoparticles, which were able to eliminate Staphylococcus aureus in ready-to-eat poultry meats. Another article I would like to highlight is entitled "The Application of Silver Nanodots for Potential Use in Antimicrobial Packaging Applications," and this is by Aslan Hazem et al. 2014 in the Journal of Innovative Food Science and Emerging Technologies. In this article, they state that antimicrobial activity of silver nanoparticles appears to be even more effective than nanoparticles of other metals. This includes copper, gold, and zinc. In this study, silver nanodots of different sizes were formed using a self-assembled copolymer, which was made of polystyrene and polyethylene oxide. During this process, a precursor of silver nitrate was dissolved in ethanol and then spin-coated onto the polymer surface. This was then exposed to a UV and ozone treatment to evaporate residual solvent and then reduce the silver ions into nanoparticles. This template created by the block copolymer can be adjusted in size by altering the monomer's molecular weight. By adjusting the template, you can then adjust the size of the silver nanoparticles. The second classification of smart materials used for food packaging applications I would like to highlight is the oxygen scavenging materials. Oxygen is responsible for oxidation, and in food packaging, this can lead to the detriment of loss of flavor and bacterial growth in the food package. According to Riolini and Marcos, oxygen scavengers are able to reduce the residual oxygen in the package to less than 0.01%. Some of the common mechanisms used for oxygen scavenging are iron powder oxidation, ascorbic acid oxidation, and photosensitive dye oxidation. Clariant produces a product called the OxyGuard, which is based on the iron oxidation principle, and instead of being used in the food packaging itself, it is an actual packet that is included into the food. A company called RPC, Bebo Plastic, launched a container made from a multi-layer structure of polypropylene, ethylene vinyl alcohol, and polypropylene, a three-layer construction. This is most likely a co-extruded film, with the polypropylene layers used for structural support and the EVOH layer used for its high barrier properties. This also contains an active oxygen scavenging system and has been used for food packaging applications. I would now like to highlight an intelligent packaging application, which would be the integrity indicators, which are used to indicate time or other information about how long a product has been open. This is commonly done in the form of a label. The label can be triggered at the point of consumption when the package is opened, and then after a period of time, the label can change color to indicate that the product is expired. Of the integrity indicators, a common indicator is the gas indicators, and this can be used to verify or to ensure that a leak has not occurred in the food packaging. If a leak occurs and the gas is detected, which the system is designed to detect, it will change a color, and the consumer will know that it has been exposed to this gas. Of gas indicators, oxygen is the most common. For this application, a oxidation reduction dye can be used, such as methylene blue, with a strong reducing agent, such as glucose. When the oxidation reduction dye of the indicator is oxidized by oxygen, a color change will happen in the food packaging. One of the drawbacks of using an oxygen indicator that uses an oxygen reduction dye is that this change is reversible. And after the oxygen is removed from the environment, the color will change back to its original form. This can be undesirable due to the end user not knowing that the product has been exposed to oxygen. A company called Emco Packaging produces small adhesive labels that can be used for food packaging that are highly permeable to oxygen, which also contains a liquid that will change color in the absence of oxygen. These products come in two forms, reversible and non-reversible. The non-reversible form is of high interest to consumers, since even if it's exposed to oxygen and the oxygen is removed, the color of the material will not change. That will indicate to the customer that this has been exposed to oxygen and may be spoiled. The last article I would like to highlight is called The Use of Phase Change Materials to Develop Electrospun Coatings of Interest in Food Packaging Applications by Chalco, Sandoval et al. 2015, published in the Journal of Food Engineering. This article highlights the use of phase change materials for packaging in the transport and storage of cold foods and beverages. During this process, sensitive foods can be exposed to swings in temperature, and these temperature variations could produce undesirable byproducts or spoiling of the food. One way to eliminate the temperature volatility is the use of phase change materials in the packaging systems. The phase change material can exhibit a phase transition at a very specific temperature, and as a result are able to absorb a lot of latent heat from this ambient condition, but only produce a very small variation in ambient temperature, thereby protecting the contents of the food package. In this study, polystyrene foam was coated with a phase change material, which was prepared through hydrodynamic process. This phase change material was identified as a RT5, which is a blend of paraffins, and the study indicated that the transition temperature was approximately 5 degrees Celsius. In conclusion, smart materials can be used in food packaging applications for both active and intelligent packaging systems, for antimicrobial, oxygen scavenging, integrity indication, and temperature regulation properties. In the future, smart materials will continue to be an area of interest for food packaging applications.